Hey everybody, welcome back to Diagnostics with Dean. Today we're going to take a look at this wiring harness. We're going to make it simple, shall we say. There's a lot going on this harness. This one connector alone has 73 terminals in it, but we only need one. So let's break this down. We're going to go through service information so that way we can find out which wire it actually is in that schematic that we need and how to properly and quickly test it. Let's dive on in. Before we begin, let's review our tools real quick. We are going to use a multimeter today, nice and simple. You could use the test leads that come with the multimeter, alligator clips that come with the multimeter, but we are not going to do that today. What I'm going to use is the regular leads. Now, to go along with this, we do want to make sure that we are probing our connectors with the proper terminal tool. So this is the one that we need for today. It is a Micro 64. I've got two of them here, and we can attach our meter to these by simply sliding into the end. So that's how we're going to handle that today. So we got a good connection with that. Alligator clips may be necessary on some jumper wires. I've got two of those here today. Always keep those with my multimeter. And then our pocket pry bar so we can take connectors apart. I'm going to show you how we can take our connector apart here in a moment. And some back probe pens. Now, these are the style that I like. I picked these up from Joann Fabric. And what I like about these back probe pens is, for the most part, they can't touch each other. Notice how those go together and they're not making contact. When we back probe these connectors, I've seen a lot of people use T-pens, and people love T-pens, but T-pens also will make contact with each other, and I have had students in the past damage engine control modules because of that. Okay, let's get started with all data here so that way we can find out exactly the information that you need and the fastest way that we can get an approach to it. So I'm going to build this vehicle out from the very beginning. This is a Buick Encore all-wheel drive. Many of you may know that this is actually my personal vehicle that I put an engine in a few months ago. So it's nice that I had that harness laying around. We were able to go through it and look at it this way. Now, a lot of times what I see is everybody likes to go up here and search for, they'll just type in crank because that's the fastest way to get to the crank sensor. And then they'll grab this all data find a fix just because it's the first thing that comes up on the screen. But what does this all data find a fix give us? It gives us a list of probable causes, right? Which is an assumption of what might be wrong. And then it will give us reported causes and fixes. So there's 21 reported causes and fixes on here. And I don't know who those 21 people are that are reporting those fixes and if that even fixed the problem. So as we look, there is literally a list of 21 different things, some of them just worded differently, like clutch pedal position switch or clutch pedal position switch connector, right? I don't trust this information. I don't want you to trust this information. It is best off for you to learn how to do the diagnostics yourself. And I want to show you now how we can make that happen. So I'm going to go back to our car. It takes us right back to the beginning screen. And sometimes all data is hard for people to navigate because we generally tend to read left to right. So a lot of times people start right here and they're unable to find the information for which they seek. But we already know we're dealing with the engine and we're dealing with our engine electrical or our powertrain management, right? So let's go over to the center and we're going to scroll down to powertrain management out of this center menu right here, right in the middle of the screen. Now, again, we read left to right. So the natural tendency is to start clicking through stuff over here on the left-hand side of the screen. And generally that does not yield the results that we're looking for. Let's make this fast, right? Going over here, we've got our electrical diagrams right here. I prefer the electrical OE diagrams, and I'll show you in a moment why. But let's click on the interactive ones from all data themselves. So this is a good diagram. It's the same one that you'll find in ProDemand. right? And there will be several of them. They've got 6 apparently. So I'll try to find our, well, here is our intake camshaft, our exhaust camshaft. Where is our crank sensor? Was it in the first one? It should be located with our exhaust camshafts because that would make sense, right? Or our exhaust and intake camshafts. There's our ignition coils, turbocharger boost, fuel pressure. Okay, intake camshaft position, exhaust, crankshaft position sensor. So that's awesome. It shows me that I have 3 wires here. It gives me the color. They're actually color coded as the color that they would be, right? GRN is green, violet with a blue stripe, black with a violet stripe. And then I see that they just run off of the screen. So that's great. I've got a colored diagram. I know that I've got 3 wires on my crankshaft sensor, but now I've got to trace this and follow it to the next page. It's going to be wire number 8. So if I go into the next schematic, I can come over here to wire number 8 and I can trace this across, and then I see that's my low reference, right? Let's do this the easy way instead of the hard way, gang. I'm going to go into the electrical OE diagrams. These are the ones General Motors actually uses for this vehicle, right? So if I look down, figure 5 here is camshaft, crankshaft, knock sensors, camshaft actuators, Buick with LUV. I have the LUV RPO code. Remember, RPO codes are our regular production options, so you need to make sure that you've selected the right RPO code for the vehicle you're working on. But now look at how nice this schematic is. Literally right here in the dead center of the page is my crankshaft position sensor. And if I look at the top, generally a schematic will flow from the top with power down to ground at the bottom is my 5-volt reference. Let me make this bigger. We'll zoom in on this a little bit so it's easier to read, and I'll slide this around. So K20 engine control module. Here is our crankshaft position sensor. This is our 5-volt reference signal. It is terminal 36. But terminal 36 where, right? If we look over, connector X2, and we'll go through how to locate those connectors here in a little bit and decipher what's going on there. Now, I do love this because it shows me my sensor here. Unlike that schematic that we had just looked at, it showed I had 3 wires. It didn't tell me what I had going on here. I can look at this and think, well, it's got a notch cut out of it. Potentially, I'm dealing with a Hall effect sensor, right? It's a circle with a notch cut out of it. Every time that spins around, I'm going to make and break my electromagnetic field here. So we're making an assumption right away with the drawing that we have here, right? Good details to know. Going down to the bottom, like I said, we do have our ground there, terminal pin 20. And if we scroll over here to the left-hand side again, connector X2. So we're dealing with the same connector for this. And then if I look at my other terminal here, my green wire that comes down, it is pin 56, still in connector X2. And it shows us here, we've got like a drawing for a variable resistor, right? So that lets me know that that is my signal. It is going to be variable. If we look over here, we've got what we would see like a switched Hall effect happening over here with that camshaft position actuator solenoid valve. So just gives us good references to look at stuff. Right now I just want to focus on this crankshaft sensor. However, let's click on this crankshaft sensor. We'll follow that hyperlink and check out what we have going on here. This is a beautiful diagram of what that connector body looks like, right? So I really like looking at these, and I want to share with you why. Number one, I know which pin is 1, 2, or 3 when I unplug this, so I could test it here. We are not going to be testing at this sensor. We're going to test at the engine control module because it is easier for us to access. But let's run down here a little bit. Harness type, engine, copy. OEM connector. All right, that's great. Service connector. This is something that I want you to think about right here. I'm going to copy and paste this service connector right now and show you what we end up getting. So over here on GM's parts website, we've got our multi-purpose pigtail. It didn't say it was a crankshaft pigtail. It said it was multi-purpose. That crankshaft sensor connector may share the same connector as many other connectors across a different variety of vehicles. So zoomed in on this a little bit. It didn't give us much of a close-up, unfortunately, but you could see, yep, that looks like the broken connector that I have in my hand right now that I need to replace. And we have white leads coming off of this. This is one of the things that makes it a service connector. When you start referencing some of their information, we can put this connector in place for our crankshaft position sensor if necessary, but you need to make sure that you've got terminals 1, 2, and 3 properly aligned, and that way you connect the correct wires together, right? So moving on from that, that's a great way to be able to get replacement parts. If you need a connector, they do have that for us right in service information. So it does say 3-way, meaning it has 3 pins, right? It gives that their multi-lock series sealed black connector. Totally fine. If we look at some of our other stuff, terminal lead, not required. Diagnostic test probe, that is the one that I had showed you for the Micro 64. And then no special tools are required for this, so that is really cool. When we take that connector apart, it is easy to work with. All we need is a pocket pry bar or a pick in order to take it apart. Historically, with some connectors, we used to have a lot of special tools that were required in order to service them. That's where you see the tray name here. Literally, it was a tray in a whole toolkit that General Motors had that we would need to select out of that tray. That's the tray where we would find the proper terminals that we needed and anything else that would go with it. But this does give us some more details on that connector. We've got pins 1, 2, and 3 here. This is all stuff that we need to look up. And it gives us the wire colors for quick reference, right? So if I know pin 3 is going to be green, it's easy for me to figure out which pin in that terminal is pin 3 because it has the green wire on it. And that one is our 60X sensor signal, right? You see that we have our low ref or our ground and our 5-volt reference there that we've seen in our schematic, but now we've just got a little more detail for that. So let's go ahead and jump back to our schematic that we were looking at, which was really nice. Now, I will say that you can click on LOC. Let's actually follow this for a hot second. We're going to click on that LOC link, and that gives us the master electrical component list for this vehicle. So it doesn't matter what you're working on, all of the schematics within the service manual, if you're viewing them this way, will give you a link to the master electrical component list. And we can roll through this list and find our module that we're looking for. So keep in mind the engine control module is always K20. So I wouldn't necessarily scroll for this all the time. We can do Control F, and that gives me find. I'm going to type in K20. It's probably not being shown on your screen yet. And there we have our K20 engine control module. So then what connector is it that we needed? Were we X1, X2, or X3? We were X2, I believe, right? And we are LUV. So I can click on this and it will take me to where I need to go. But let's jump back here quick and I'll show you the easier way to get there. Click on our schematic, make it big. Engine control module right here, right? If you want me to zoom in on it, I will. Engine control module K20. We can click on that. That will take us right to that. So the hyperlinks that they have built into these documents are super, super helpful for you to figure things out real quick. But if you've got one that's not hyperlinked, keep in mind, clicking on LOC will get you where you need to go. So digging through our connector here, we can see all of our details. Again, we've got a service connector that we can get for this vehicle. So if you want, we can copy that real quick, and I'll throw that into this GM parts list and see if they can find that connector for us. I'll be curious if they can or not. I did not pre-try this one. So they do. They have that connector. No image is there for it. That is fine. Actually not badly priced. I'm surprised it's only $33. But jumping back over here, this will give us some more details about this connector. It is a 73-way, meaning 73 pins, correct? And it is black with black terminal position assurance. We'll jump over to the harness and take a quick look at that in a moment. It does have a couple of different things here though. We've got terminal removal tools listed for this. We can get a service terminal. So that means that that terminal is going to be able to be replaced, right? I was just trying to look to see if we had our reference for terminal ID 1 and terminal 2 on here, and we do not, but I'm not too concerned about that at the moment. You will see in this connector, all of these terminals are going to be the same, 1 through 72. Terminal 73, obviously a different terminal. Generally, what we will see when we have that one large terminal is that may be a PCM power, or that may be a PCM ground supply. And we'll check that out in a second, because we have a list down here of what all of these terminals are. So some of our terminals will be serviceable, some of them will not at this time. And it actually looks like the micro 64s are going to be the ones that are not serviceable, because if I look over here, that 64B light blue tool is the one that we were using. So we are not going to be able to get that service terminal, but we can get a terminated lead for that connector. So let me just jump here quick. I'll show you what that terminated lead it will look like for us. Pretty cool, huh? So with a wire already crimped on there, you can get, looks like it's going to be a pack of those. And I'm not seeing how many on this list, but I would say there's 1, 2, 3, 4, 5 in that image right there. So pretty cool way of doing it. You get that terminal lead. Think about this for a second. Why would they give you a terminal lead instead of just the connector terminal itself? So I really think they've went a good method with doing it this way, because what I have found in the field is a lot of people have replaced those terminals but didn't add a section of wire. So now that one wire, let's say we're working with our crank sensor wire, has become too short, and we are creating strain on it. So jumping back into all data, I won't bore you too long with that. If you can remember back from our schematic what wires we were dealing with, the one in particular that we want is 53, correct? No, not 53. I was wrong. That was a different schematic that I was looking at. 56. So 56 is our crankshaft 60X sensor signal. So let's jump on our harness and see where that is located at and how we can potentially do our testing. So we have our 3 ECM connectors here, and I'm just going to tip these up so you can see. We've got one that has a blue terminal assurance, the black terminal assurance, and this one has a gray terminal assurance piece inside of the connector. Now this is the piece that actually holds the terminals in place. If we were to pop this out, and I'm choosing to use the gray one. I know the black one is the connector that we need to work with, but we're not going to be able to see it on the black connector as well. Now I have access to all of my terminals in there. You can see they're nice and shiny and silver. The terminals that are there, is every hole supposed to have a terminal in it? No, right? Now in order to remove these terminals at this point, there is some stuff we have to do on the back. We do have a zip tie holding the harness together. But these terminals do pop out of here fairly easily now once we move the one tab out of the way. So let's move to our connector that we actually need for testing and our back probing. And I'm going to flip that over and pop the cover off of it on the back side. So if we look at this, you will see that there is going to be tabs on both ends of this connector. And we can pop that up. I'm going to rotate it over, pop this one up. Then we're going to kind of lift and pivot that out. So this gives me all of my wiring here now, so that way we can see what we need. I'm going to refer back to the schematic and pick the proper terminal and do our back probe. So you won't be able to read this on here, but looking at our connector in view from service information and looking at the back side of the connector here as well, this is labeled 53 right here where I have my screwdriver. If we go over 3, that is going to be 56, and that has our light green wire in there. So this is the wire that we're going to back probe, and our back probe is our simple pin that we had there, right? So I'm going to stick my back probe in there, and then I really do prefer to use test leads for this or alligator clips, just because I generally get a very good connection with that. So I'm going to put my alligator clip on that. We'll zoom you out a little bit so we can throw the multimeter in here as well. And what do we need to be set on with the multimeter? We need to be set on ohms, correct? So put this over on the omega symbol. I am going to connect one of my leads to that alligator clip. I am going to just double check to make sure my meter works real quick with my other piece on there. Try and get that so you can read it. My apologies. So we want to test our meter to make sure we've got continuity, and we do have continuity there through our test lead. So I am going to go to the other side of my connector now. I want to verify that my back probe is making connection with my terminal inside of the connector. So I've done this a few times before where it has not. So let me get this turned over. 53, 54, 55, 56, and then gently push that in there so that way we have a good connection. And it looks like we do not have continuity here on our meter. We still are open loop, right? So let's go back, reevaluate where we've connected our pin at. And there we go. So simple, small, little slight adjustment to that pin. And now I've got continuity, so I know my test is going to be good. I have made this mistake before when I back probed something and I did not have good continuity. So I will also generally shake that, move it around, make sure that I don't lose my continuity on my meter at that time. I can put all of this back together now and go ahead and do my test. I should mention while we're here too, we can put this multimeter on a beep setting right there. So you might notice that the little beep has came up, and then I can go back if I'm testing for my continuity. And if I have continuity, we will have our meter beep. We don't have good continuity there for some strange reason. Let's double check that. There we go. Actually, it was a poor connection in the switch on the meter, so a good thing that we double checked and everything is good. Okay, let's wrap up where we're at with this. Today we covered how to find our electrical schematic and all data, and how to do our proper back probe to verify that we have continuity, just simply using our multimeter. So I hope you got some good takeaways from today. This electrical connector here in the PCM, out of the 3 that we have here, right, one of them has 73 wires in it. It doesn't have to be confusing, gang. Countless times we've had these discussions and I'm like, man, electrical's easy as long as you've got the road map and you can follow your map. And that's what we did today. We pulled out our green wire for our crank sensor signal, figured out what terminal it was located at our PCM connector, disassembled the back side of our PCM connector, and then performed a back probe so we can test that. Next time we do this, we'll have it on the car. I'll see you then.